In part 2, we'll go from a brand new app to a working prediction. I'll build 2 cars, one with a Titan clutch and one with a generic clutch. Record a baseline, run a full prediction with weather, a dyno sheet, and a data log, and then compare setups to read the difference. Follow along with your own numbers. Pause if you need to read the inputs. This is a one-time snapshot of your clutch as it was delivered or last freshened. It's your reference point. Later, when you've been tuning all season, you can pull this up next to your current numbers and see exactly how far you've moved. We're on a Titan clutch, so I'll fill in the base configurations. These are numbers off the build sheet. Click Save Initial Setup. This is now the baseline and it's locked in as our reference. Notice the numbers here. 30-gram levers, quarter-inch preload, and when we build on our race day setup in a minute, we'll go heavier. The comparison tool will show us what we did to lock up. Navigate to the Vehicles page. Click New Vehicle. In the garage, each car is a vehicle, and each vehicle can hold several setups. Think of a setup as a saved tune. We'll build our first car. We'll click Save Vehicle. As you can see, I added the transmission gear ratios. This is important for the data log, so make sure you get it right here. On the free trial, you get 1 vehicle. We're on the race tier, so we can add as many as we want, which we'll do for a bit in a generic car. From the Vehicles page, navigate to the Predictions page. You can select your vehicle and a blank setup because we'll save this as a new setup. We're going to adjust spring preload. We're also going to adjust lever weight. We can see in this note below, lockup moves about every 585 RPM per 50 thousandths of lever height, and 365 RPM per gram of weight. That's why we have these tuning knobs. If we open Advanced, we can adjust other inputs. We're going to change the number of discs to 3. And we're going to change this to 10.5. Under Advanced Settings, we'll see parts of the clutch that we'll rarely touch. Lever angle, disc count, diameter. Leave the clamping factor blank, and it's computed from the geometry. Next is the weather. This drives the SAE horsepower correction, so your prediction matches the air that you're actually racing in. You can type it in or import your weather station file. This can support Race Air, Crew Chief Pro, or Raceworks files. If you don't have a weather station, that's fine. You can type it in manually or approximate what you might have thought your run was that day. I'm going to import my Race Air file. As we can see, it automatically fills air temp, barrel pressure, and humidity, and gives us an approximate horsepower correction factor. Below, we can see our clutch scale factor. We'll leave this at 1.0 for now, but this is a calibration knob. When running your car in real life and finding out the real lockup, you can use this calibration knob to match your actual data. Now for the dyno sheet. We can either import a logger CSV to calculate our dyno sheet, or enter each horsepower point at an increment of 500 RPM. I'm going to go into paste mode and upload all of my dyno sheet data at the same time. We're now ready to run our prediction. You can either press the shortcut of the Enter key and run the prediction, or click the Run Prediction button up here. At the top, we'll see lockup RPM, our peak slip, our average slip, and the clutch type. Below, we'll have graphs of the engine versus clutch torque, the engine versus clutch horsepower, and the slip percent versus RPM. These are expandable, and below, we can see the slip percentage table, where we can analyze each exact point. Our comparison feature allows you to either compare your initial setup or pin a prediction as a reference and run another so that you can see the difference. First, we'll compare versus our initial setup. We can see the changes in deltas based on the differences we had in the clutch setups. In addition to comparing with our initial setup, we can pin a setup as a reference and then adjust an input and run a prediction. We'll see here that our current inputs change the lockup RPM, and the charts show the differences. Now, if we're happy with the setup, we can save it to this vehicle. Navigate to the top and press Save as New. Give your setup a name. We can also log this run to history. Where if we go to Historical and click Load, we can view our run. We can also choose to delete or rename this. Logging a run to history saves this prediction, its inputs, its outputs, the whole thing. You've got a permanent record. It's all here on the historical page. Every prediction you've saved is filterable by vehicle. By contrast, not every vehicle has a Titan branded clutch. Some vehicles might have different clutches, so we'll build a generic clutch for our next vehicle. This is a Tier 3 and race feature. The generic model has the same physics, but exposed a little differently. Instead of Titan spring math, you give it base plate load, clamping force at 0 RPM, and flyweight, as seen here in the generic clutch. We can either choose to do direct or spring. In our Predictions tab, we can select our new vehicle, and we don't have a setup yet because we'll build that now. Then we'll navigate to generic clutch. We'll put the base plate load as 850, the lever weight as 28, and change disc diameter to 10.5. If you've measured plate load at 2 RPM points, use the Derive K2 helper to compute that coefficient for you. This is how you model a clutch that isn't a Titan clutch. We'll import a weather file and we'll paste in our dyno sheet. We'll put a shift point at 7600. We can now understand our prediction of our generic clutch. Labeled right here, we can see our clutch type, and labeled in our graphs, we can see S1 marking our shift into second gear. If we like this, we can log this run to history. And save the setup. Now, the data is saved locally, and this data will never be lost. One thing to know about how tiers work, because it protects your data. On the trial or Tier 1, once you run a prediction, that setup's dyno sheet and disk size lock. You'll see a little padlock note. That's by design. It keeps a saved prediction honest to the numbers it was made with. On Tier 3 and Race, they stay fully editable. So on Race, like we're running here, nothing's in your way. That's the full prediction workflow. In Part 3, we take these predictions to the track, log real runs, and attach the data logger to compare them.